going. Good afternoon, good day for those who are visiting us via the internet. Welcome to our side event on keeping 1.5 alive, opportunities and challenges for carbon dioxide removal and storage in the global south. We have one or two speakers who will join us a bit late, so the agenda might change slightly while we go along. The objective of this event is to provide you with information on the status of carbon dioxide removal and geological storage as a key part of achieving net zero and then net negative goals, and the critical role they are playing in the case of overshoot, which, as we know from AR6, is now slightly more likely than not, but 1.5 is still achievable, but there is a risk. There are issues, of course, while scaling up carbon dioxide removal, things will come along with challenges and opportunities for both sustainable growth of developing countries and could offer efficient large-scale deployment and driving job description. But let me not talk too much about what might come or not come. Let's dive into the agenda. We'll start with opening remarks from James Morombezi. He's the Chief of Climate Change Section at the United Nations Economic Commission of Africa. And he is also in charge of climate change, natural resources, and technology. James, over to you.
Thank you very much, Kai. Good afternoon, colleagues, ladies and gentlemen. So I have a few points to make. The first is that, and following on the sixth assessment report of the IPCC, as well as the WMO State of Climate Change in Africa report for 2021, that it is almost beyond doubt that Africa is probably going to warm beyond 1.5 degrees by the end of this decade. And in fact, at the end of last year, according to WMO, Africa had, or most of inland Africa, had warmed by between 1.1 and 1.4 degrees. So Africa is warming faster than the rest of the world. And certainly Africa needs more urgent solutions than the rest of the world. We also take note of the fact that according to the IPCC, and for almost, in fact, for every scenario for reducing emissions and global warming, the carbon capture and storage technologies are part of every solution. And in that regard, on the continent, we have many years of experience with nature-based carbon capture and storage, mostly in the form of REDD+ and related interventions. However, we also take note of many of the challenges that need to be resolved before the carbon capture and storage and use technologies can be broadly disseminated. I think the first set of challenges is around the policy and legislative environments to regulate both the technology but also the application and deployment of different technologies. These challenges are based in the context that the atmosphere as a global commons, in fact, is actually affected by activities that occur at local and national levels. But the state has authority over territory and not necessarily over the whole extent of the atmosphere. The state is a Westphalian construct. Now this presents the challenge that what happens in one state in terms of emissions actually affects what happens in the whole of the atmosphere and what happens everywhere. And therefore what happens with carbon capture and storage technologies potentially also has implications beyond the territorial boundaries of the state. And so the policy and legislative challenge that we face is that we do in fact need to have multi-level policies, possibly polycentric governance systems which are capable of regulating the nature of the technologies within the territorial boundaries of the state, but also the impacts beyond. And from an African perspective, and we are aware that the Africa Group of Negotiators has taken no position, or rather the position of the African Group of Negotiators is that we need more information on the nature and impacts of these technologies before the continent can take a position. And so our first point is that we really need to develop multi-level policies and governance mechanisms to ensure that the development and deployment of these technologies is to the benefit of the continent. And linked to this first point is the very real possibility that, in fact, carbon technologies can also be used for weather modification, and that would be to the detriment of the continent. The second point that I would like to make is around the question of the cost and benefit of the production and deployment of carbon capture technologies. These are technologies that I think have been in existence for quite some time, but I think the general assessment is that the performance has not been universally proven to be positive. These are very costly technologies in some instances, and the benefit of the deployment of those technologies, I think, has been questioned in some contexts. This is not to dismiss the efficacy of the technologies, of course, but simply to argue that we need to have more information. More information, firstly, to inform the policy and legislation that I've talked about, but also more information to inform the investments in these technologies. Oops. Excuse me, that's my phone. I think there's also evidence to demonstrate that the actual effectiveness of carbon technologies in terms of capture of carbon is still relatively low. So only a fraction of carbon is actually currently captured by existing technologies. And perhaps there is potential for further development to ensure that the technologies are effective both financially but also at a carbon capture technical level effective. In other words, we probably need more research, more investigation on not only the financial intensity but also the carbon effectiveness of the technologies. Finally, also within that technological perspective is the issue of the energy intensity of carbon capture technologies. How much energy is actually required to drive these technologies, and what are the implications in energy deficient contexts such as the African context in which we operate. My final governance question is particularly addresses the issue of nature-based solutions, nature-based carbon capture and storage. And again, is based on the long years of experience that we have had with REDD+ and similar interventions. Here, I think the policy and governance questions for the African context is that we would need to resolve the different governance regimes in which the ecosystems that store, sequester carbon are governed. There are many big tenure questions on the continent, many tenure issues which actually act to disempower particularly local communities, or which act to give inordinate power or control over resources to non-community interests. So there is the potential that unless we resolve the policy and governance questions, that in fact carbon capture in the form of REDD+ and related initiatives could constitute a new form of disempowerment, a new form of resource expropriation, depending on how the how the investments are regulated. So this is not to say that these technologies, as I said at the beginning, are not desirable. I think for the African continent, we really need to ensure that all potential technologies to reduce the rate of carbon, of global warming are deployed. But our point is that the continent needs to be at the table in developing the mechanisms of regulating the deployment of these technology. The continent cannot afford to be a latecomer into that scenario, as it were. Thank you very much, Chairman.
Thank you very much for your opening remarks and the 4 points you raised. Let me just, for the sake of time, just move on in the agenda. The next part is, I'm happy to welcome Thelma Krug. She's a Vice Chair of IPCC. I guess I don't have to introduce her, many of you know her already. And she's providing us an introduction to CDR and capture and storage and what the IPCC says about them. For this we have a presentation. How does it work? There we are. It's coming there. I think you can start. You can see it now.
Okay, let's start. Okay, hello everybody. Good afternoon to all, and I thank C2G, maybe this is too close, C2G and CO2 GeoNet for inviting me to be here today and set the scene for the presentations to come. So I always like, to give this big introduction. In 8 minutes, you don't do much. What is happening? Yeah, no, it's worse. So I only have 8 minutes to do this, and I will do my best to be very focused. And I will start with the definition that IPCC provides for carbon dioxide removal. In short, we say CDR. And IPCC definition is that CDR refers to anthropogenic activities that deliberately remove CO2 from the atmosphere and store it durably in geological, terrestrial, or oceanic reservoirs, or can also store it in products. So I think the key word here is store it durably somewhere, right? So in products, in geological sites, ocean sites, and terrestrials. So there are, next one, I forgot to say next one. Who is changing? Yes. So you can see the definition there. And there are many processes by which one can remove CO2 from the atmosphere, including the enhancement of biological carbon sinks, enhancing geochemical carbon sinks, and also direct capture of CO2 from air. So there are several ways you can do it. So next one. I will not go into detail because of the 8 minutes. But yeah, okay, so many of you may remember this figure on the left. And this comes from the IPCC special report on global warming of 1.5 degrees Celsius. And what does it mean? That figure has the emission pathways that were assessed by the IPCC and that limits global warming to 1.5 at the end of the century. Okay, so there is not a single way. You have a huge number of ways where you can get there in terms of emissions. However, when you use, with different implications, obviously. Nothing comes for free. So the ones you see in blue, which capture many pathways, all limiting global warming to 1.5, we call them pathways with no or limited overshoot. So what is our overshoot? Overshoot is when you have a temporary exceedance of the temperature. Say, if you want to, if your focus is 1.5, we would say that you have a limited overshoot when you go above 1.5 by 0.1 degrees Celsius, for instance. And then you bring it down to 1.5 at some stage by some processes, right? And what you see in gray, those are pathways with a higher overshoot. So higher overshoot, they're exceeding the temperature by more than 0.1 degrees Celsius, and obviously to bring it down, it's gonna be much more complicated. But anyway, it is not impossible if the overshoot is not too large. So, in all of these scenarios, in all the scenarios that also have been modeled, CDR was present, or at least in most of them. You would find that they relied to some, you can go back. You can go back to the previous one, yep. So it relied on carbon dioxide removal. And carbon dioxide removal has many potential, okay? So it has a lot of potential, either to enhance the mitigation actions, but also to compensate for those residual CO2 emissions that could not be zeroed by around 2050. And finally, obviously, you know that all these scenarios, I possibly forgot to say that, all these emissions and pathways here, they all have net zero CO2 emissions by around 2050, okay? So, CDR is also useful when you cannot zero your CO2 emissions by that time. So CDR could be used to compensate this residual CO2, which would be difficult to decarbonize or very costly to decarbonize. And finally, CDR is also useful for getting into the negative CO2 emissions. And this is why CDR is also referred to as negative CO2 emission technology. The next one. So, the deployment of CDR will lead to a reduction in atmospheric CO2 levels only if the uptake by sinks are forests, the ocean, exceeds the net CO2 emissions. Hence, there could be a substantial delay between the initiation of the carbon dioxide removal and the net CO2 emissions turning negative. The time to reach these net negative CO2 emissions and the evolution of atmospheric CO2 and climate thereafter would depend on the combined pathways of anthropogenic CO2 emissions, CDR, and natural sinks. So the cooling or avoided warming due to CDR would be proportional to the cumulative amount of CO2 removed from the atmosphere by CDR. The next one. But when we are talking about CDR and talk about these options, which options are these? There are many, as you can see, a full list over there. Most of the models that IPCC used, the model pathways that I showed, the blue and gray, they relied on afforestation and reforestation, basically, and also bioenergy with carbon capture and storage. We call them BECCS. And in a small proportion also the direct air capture and the storage, the DACs. But you can see this whole list of CDR options, including peatland and coastal wetland restoration, agroforest, improved forest management, soil carbon sequestration. Obviously, the IPCC explores the potential of each one of these options, and you can find this specifically in the IPCC report on mitigation, more specifically chapter 12.6. So, and then this picture shows on the left, you have just an example of BECCS. Oh, sorry for this. Okay. And on the right, just a nice diagram of afforestation and reforestation. But the message in this slide is the larger you have the overshoot, the larger is the exceedance of the temperature in relation to your target, which would be in this case 1.5, for instance, right? So the more net negative CO2 emissions will be required. Also, nothing comes really without some, nothing comes really without some sort of issues related to all of them. In particular, when you have large scale afforestation, reforestation, or large scale BECCS, or which can have some effects, including in the Sustainable Development Goals. So you may do good from one side, large scale could bring you with some problems to deal with afterwards. So there may be risks from maladaptation and adverse side effects of some emission reductions, and also from some of these carbon dioxide removal measures. For instance, deployment of afforestation in naturally unforested land or poorly implemented BECCS, bioenergy with carbon capture and storage, can compound climate-related risks to biodiversity, water and food security, and livelihoods, especially if implemented at large scale and in regions with insecure land tenure. The next one. So the CDR, as I already mentioned, may have side effects, which can either weaken or strengthen the carbon removal or the cooling potential of the options. Deployment of CDR, especially if in large scale and without the proper management, can, as I already said, affect the water quality and quantity, food production, and scale. But also, just to finalize my presentation, the title of my presentation also included carbon capture and storage, and you already heard about two of the options in CDR doing exactly this, right? So that's the DAX, the direct air capture and storage, and the bioenergy with capture and storage. And this is my last slide, the next one. And what does IPCC says about the CCS, carbon capture and storage? The IPCC mitigation report concludes that CCS is an option to reduce emissions from large-scale fossil-based energy and industry sources, provided that you have geological storage. So when CO2 is captured directly from the atmosphere, as in DAX, or from biomass, as in BECCS, CCS provides the storage component of these CDR. So if the geological storage is appropriately selected and managed, it is estimated that the CO2 can be permanently isolated from the atmosphere. So implementation of CCS is not easy as well. You need the storage capacity, but you also have some barriers presently, which would go from economical, technological, institutional, ecological, environmental, and also social cultural barriers. Currently, the global rates of CCS deployment are far below those that were projected in the model pathways that limit global warming to 1.5 degrees Celsius or even 2 degrees Celsius. So enabling conditions such as policy instruments, greater public support, and technological innovation could reduce these barriers. So with this, I hope to have given just a broad overview. CDR, differently from other approaches like the solar radiation modification, for instance, is something that is a must. We will not get to 1.5 without some level, some scale of carbon capture and storage. Whereas SRM is a little bit different, but it's not the topic of this presentation. But we are not relying on it to get to the net negative CO2. And so we have to cope with it and do the best we can in terms of emission reduction so that we don't have to rely on large scale CDR deployment. Yeah, so that's the message. Thank you.
Thank you, Thelma, for setting the scene on defining what is overshooted, the relation of CDR in those scenarios, the importance of it. And you also mentioned the critical role of storage, which is a nice way of leading on to the next presentation. Ceri, Vincent, the president of our co-organizer CO2 GeoNet, is going to enlighten us around the role of storage. And yeah, let me just hand over to you. I think you have also a presentation. Can we have the presentation for Ceri, please?
Okay, try that one. Okay, so I will start talking. Excellent, you have my slides. Thank you very much. So it is great to be here, and I really hope you can hear me. The microphone is a little tricky. So I wanted to tell you a little bit about CO2 capture and storage, which is a flexible and ready-to-go technology and one of the key options to help us meet our climate challenge and to achieve net zero by 2050. Next slide, please. Next slide, please. Okay. Yeah, so we're good. Okay, so CO2 capture and storage relies on mature technologies. We've been capturing CO2 commercially since the 1930s. Some of the oldest pipelines that move CO2 across land have been in place since the 1970s. And we have been storing CO2 since the 1970s. So these are mature technologies. These are things that we know how to do. And of course, most recently and very excitingly, we see direct air capture starting to emerge as a good technology. So it seems that we need this very much to meet our climate targets. We've been talking about climate for a long time, and we see that we go from we need CCS to now we even need negative emissions. Okay. We need more and more negative emissions to meet our climate targets. So I would also mention in terms of experience that nature has been storing CO2 for millions of years in natural CO2 reservoirs. So nature is already ahead of the game, and we see that this is something that can be safely done and something that can really help us make an impact now on our targets. Next slide, please. So how does CO2 storage work? So geological storage relies on storing CO2 in the natural spaces in reservoir rocks. So it's a bit like storing CO2 in a big sponge, and we have to make sure that it's trapped safely underground beneath a big, thick geological seal. So it takes a lot of effort for us to put the CO2 underground, and we want to make sure that it stays there. So we see this safely being done in many places across the world. I will talk a little bit later about the Sleipner project, which has been working since 1996. So for over 20 years, that first project has been storing CO2. And we can see that the CO2 is safely stored at a depth of around 1 kilometre, which is the typical depth where we try to store CO2. And this is a really good option to allow us to take the CO2 and to trap it safely underground. So in the same way that oil and gas is trapped for extended periods for millions of years, we can also trap the CO2. Next slide, please. So how can CCS help us meet climate targets? So it's something we can do now. It enables a significant and rapid reduction in emissions from any large fixed CO2 source. So this might be a power plant, this might be chemicals, petrochemicals, or commodities like steel and cement. So for steel and cement, it seems particularly important because the CO2 is manufactured as part of the process. So as you make steel and you make cement, the chemical reactions generate CO2. So we don't have good options to replace this. So for cement and steel, this is the only option that we currently have, which will allow us to significantly reduce emissions. It can help to offset hard-to-abate emissions. So for example, the agricultural sector and the transport sectors are very challenging to decarbonise, and CCS here can help with the transition and help us achieve a net zero future. And it can also offer negative emissions when coupled with direct air capture or bioenergy with sustainable biomass. Next slide, please. But it's very important to note that it's not just CCS. It works alongside the other measures to achieve climate targets. So the IEA, for example, prepared a report on energy technology perspectives and said that to start with, the focus would be on power and industry with CCS at the start of the assessment period towards between 2020 and 2070. And towards the end, it becomes something to look at removal of carbon dioxide and offsetting as a good way to help us meet our climate targets. And we see that we really need to change the way that we manufacture energy, the way that we use it, and the way that we think about these commodities. Next slide, please. So where can we store CO2? So we see opportunities across the world to store CO2. And we have significantly more storage capacity than we need. So for example, in Europe, we have more than double the amount needed to meet the 2 degrees target between now and 2050. Next slide, please. So where are we storing CO2? So this for me was a very exciting report. I looked at the Global CCS Institute report for this year, and they said that they noticed a 44% growth in the number of CCS projects coming along compared to last year's 2021 report. So there are now 196 large-scale CCS facilities. Some of these are operating, some of these are under construction, and some are in the various stages of preparation. So we see that the operational plants can store nearly 43 million tonnes every year of CO2. So this is wonderful news that every year we take 43 million tonnes of CO2 and we store it safely underground. The projects under construction can store a further 10 million tonnes every year. So we see that we now have the capacity to store around 50 million tonnes every year, which is fantastic news, but we need to do more. So there were some noticeable activities in 2022. For example, in the UK, the DRAX project announced 8 million tonnes per year bioenergy plant. Orca in Iceland became the first commercial direct air capture project. And Occidental and Carbon Engineering announced in the USA that they were building the first of 70 facilities they planned to build by 2035 for direct air capture to enable negative emissions. Next slide, please. And of course, it would not be a presentation on CCS if I didn't mention the Sleipner project. So this is the longest running large-scale project. It's been storing 1 million tonnes of carbon dioxide deep under the Norwegian North Sea for over 20 years. And so here they take CO2 from the natural gas stream and they put the CO2 underground rather than taking it onshore. And this was encouraged by the fact that there's a carbon tax in Norway, so they could either store the CO2 or pay the tax, and being very forward-thinking, they decided that they would rather store the CO2, and it's been a wonderful example for how CCS can operate. Next slide, please. So just to mention that Global CCS noted that at the moment the operational plants store around 40 million tonnes to meet the scenarios laid out by the IPCC. So there is a lot of work to do to scale this up. Next slide, please. So what's next for CO2 capture and storage? So we see it growing. You can see from the Global CCS report that CCS is growing. So CCS has a key part to play in a just transition to a low-emission future. It's an opportunity for economic growth and job creation. So we see the scale of the oil and gas industry, and we think, well, why not do CCS? Why can the CCS industry not become a climate technology and a climate market that will replace the oil and gas extractive industry? So we can replace jobs, we can keep industry going, and we can still meet our climate targets. So what do we need to grow CCS? We need well-defined governance, we need a clear and consistent policy landscape, we need a level playing field for financial mechanisms that will help CCS alongside other climate-friendly technologies, and of course, we need more real projects. So I hope next time that I talk to you, there will be even more than 196 projects. Next slide, please. And thank you very much for your time.
Okay. Should use what? Let me use a proven technique. Same microphone, stick with what you know. Thanks for that presentation. Very helpful to, I think, the picture behind what it means to store where we can store, what is the potential, and relate this. Thank you very much for that. We have two colleagues joining the panel. Thank you very much for making it, both of you. The wingman, well, man in this case. Thank you very much for being there, and let me actually bring you back into the agenda. First, I would ask you, Sangmin, he is the Director for Environment and Development of the United Nations Commission for Asia and the Pacific. Tell us about the role of removals in national determined indices of Asia Pacific. Over to you. Thank you very much.
Thank you. So I was told to speak about the nature-based solution in Asia Pacific. So previous speaker nicely covered the current CCS. Many are actually existing in Asia Pacific, but it's not a PPT presentation. Few information about nature-based solution in Asia Pacific. So we have a look at UNESCAP. We are currently covering 49 regional member countries, from Japan to Turkey, from Australia to Russia. So out of 49 member states, 21 countries have quantified NBS, nature-based solution, in their NDC. Especially 16 countries, they have also identified nature-based solutions beyond forest, so which means including marine environment as well. So it is quite common that, as you are well aware, especially last year, so in COP26, countries were again mobilizing their global alliance, global partnership on forest. And then many countries, for our member state, Mongolia was announcing 1 billion tree project, and Saudi Arabia also announced a 20 billion tree project. So it is really gaining attention, and countries are increasing highlight nature-based solution there in their NDCs. Meanwhile, this is, of course, it is not only for addressing climate action, but it has a multiple co-benefit, not only for ecosystem management, but in many other areas. But I also see there are some challenges, like Indonesia. Currently, their GHG emission, more than 50% comes from land use changes and forestry. Not unlike many other countries where major emissions are coming from energy sector, but for Indonesia, one of our top 10 major global GHG emitter, but more than 50% comes from non-energy sector, especially agriculture and forestry and land use change, which is about 950 million ton per year. So Indonesia is planning to also achieve carbon neutrality by 2050, 2060, which means that they are planning to reduce their emission by 500 million ton. And then out of 500, so in order to achieve carbon neutrality, they are planning to absorb about 300 million ton by nature-based solution, which means while they are currently emitting 650 million ton from this sector, they have to completely reduce the emission from this sector, and then further down, increase its sink capacity by 300 million ton per year. So how to realize this kind of ambition? Also, in our member state, Cambodia is also planning to achieve carbon neutrality by 2050. In doing so, they have to increase their carbon absorption capacity by 50 million ton per year, and then Thailand 120 million ton. So, but most countries are now, they have to start from now. So there is a technical feasibility, how to really enable countries to make such huge investment and at a great speed, so that they can completely convert the current forestry and their land use change as a source of emission into major sink of natural sink of CO2. So this is one challenge we are looking at while we are encouraging countries to adopt nature-based solution into their NDCs and long-term development strategy. And then also sustainability. So how to ensure sustainability? So we have seen this forest fire this year and then last year. So once a forest fire happens, we are completely losing the savings that we have made. And same story for Indonesia, because of a pit fire, that's why they are making this much emission from forestry sector. So how to really ensure safety of those natural sink so that the emissions absorbed can be kept. And then financing. So for many cases, it is not bankable project. Tree planting is not certainly bankable project. So how to mobilize resources beyond the public sector? It requires a huge investment from private sector. And then, but the current international global level investment in this sector is less than 0.6 to 1.4%. So it's very minor. So enabling financial investment in this sector will be key. In that case, of course, carbon pricing will be a key tool so that private sector can put their money in this sector. And then so without strong carbon pricing instruments, it wouldn't be possible to attract investment in expanding this nature-based solution. And then this mobilizing this sector, planting trees, quite a labor-intensive work. But many countries are experiencing losing labor force in this sector, and then also aging society. It's quite common across the countries. So how to mobilize workforce in making such extensive nature-based solution project? That will be key challenge for that. In that regard, so our regional review, UNESCAP's annual review of climate ambition for Asia Pacific, we propose a few points on. One is, of course, strengthening commitment in nature-based solution into next updated NDCs. As I mentioned, about 40 countries already incorporated, but it's the level of commitment is very weak, and then the level of quantifying the impact benefit is very weak. So it is important to highlight, quantify the impact of a nature-based solution in NDCs. And also so expanding MBS beyond the terrestrial environment, especially marine. So now we are really increasingly talking about ocean-based solution. Green shipping is one, but in the context of ocean-based solution, expanding mangrove, sea glass, coral reef. So increasing their absorptive capacity will be key as a part of these nature-based solutions. Also, investing in nature-based solution across national border. I mean, many cases these transboundary areas are untouched, so, but proper management is quite important. So it is required transboundary cooperation for really enhancing nature-based solution as a regional or bilateral work on climate change. With that, let me conclude my intervention. Thank you.
Thank you very much. Concerns a clear picture about the challenges faced in integrating and considering removals, nature-based solutions in particular in your region. Let's transition over. We were on this continent, we went east, and now let's move west. Let me ask our friend Santiago Lorenzo. He's the head of economics and climate change unit in the Division of Sustainable Development and Human Settlements at the United Nations Economic Commission for Latin America and the Caribbean. He will talk a little bit about tools which are there or could be there to support the implementation of carbon dioxide removal measures in the Latin America and Caribbean. Over to you, Santiago.
Thank you, Kai. I'm pleased to be here. And Well, I want to just introduce a little bit of work that we are doing in the Regional Economic Commission for Latin America and the Caribbean. Basically, we frame these potential solutions under larger umbrella that is the opportunities, the economic opportunities that in some of these initiatives we could have. So next, please. Yes, the context is that the region has contributed really not much to climate change. The whole region is between 8 and 10% of historical emissions, and but it's highly vulnerable to climate change. So we have from the Caribbean and Central America that they are really, really vulnerable to extreme weather events and also to chronic climate changes. To many other regions, the Andes and the northeast Brazil, etc., north of Mexico as well, they are really extremely vulnerable and exposed to climate change. So, and historically, because the development pattern, also we have been losing a lot of forest coverage due to the expansion of the agricultural and livestock frontier, and that per se was a problem. Now with climate change, it's more acute, and you have seen not only in the northern western hemisphere there are wildfires. Also, we have had a lot of wildfires. It's not only now the agricultural frontier, but also expansion, but also the drying of the forests that are making them much more exposed to being lost by wildfires. Next, please. In that regard, our approach as an economic commission is to understand the dynamics, the economic and social and environmental dynamics of all the factors, and we see that we need also to fight poverty, and for that we need to grow the GDP, and we know that because of the COVID pandemic we had a loss of 12 years on fighting poverty. We need to recover that time and to continue working that, and we need to grow the GDP around 4% and to make a very decisive distribution of income, and at the same time to reduce our ecological footprint. All of that, we frame it in the big push for sustainability. And why I'm referring this now? You should question. Well, the initiatives that for capturing and storing CO2, some of them are really address these three needs, because you can propose some policies on capture and storage, but if they don't have the economical, social, and environmental feasibility, probably they will be behind what really is going to be done. And we have, from a study that we carried out with C2G and also the Foundation and the Institute Torquato Di Tella, we have some examples that how some of these initiatives really deal with the constraints, the historical and structural constraints that our countries have in Latin America and the Caribbean, but also some other countries in the world. So next, please. From the analysis that we get, this big push for sustainability, we have some sectors that are critical for the new push for development in Latin America. And these sectors come from the transformation from the energy sector, sustainable mobility, digital revolution, healthcare, manufacturing, but also bioeconomy and nature-based solutions. That is critical, and you know also it has to be done properly, because Latin America hosts around 10 countries that are mega diverse. So the richness and biodiversity of the region is amazing, and that's also a potential for bioeconomy. So that will link a lot with the need to afforestation as a way of capture and storage. So that's just a background. Next, please. So we have calculated some multipliers of nature-based solutions. Yes? No? Okay, sorry. Well, I'm Santiago Lorenzo. This will not stand, so just for you to so we have seen that all of the solutions on meaning forests, the management of forests, all of them bring interesting multipliers for investment. So if you invest $1 in some activities on forests, you will have much more than that because the co-benefits of that. So that's something that is already an economic issue. It's not only an ecological issue, it's an economic issue. Next, please. So our study went through, we prioritize the analysis of the potential of carbon and storage initiatives with four. We carried out this study in Argentina and Colombia, and we made calculus for afforestation and forest ecosystem restoration, land restoration, soil improvement with biochar, and bioenergy. For Colombia, we added mangroves because Colombia is one of is within the 20 largest owners of mangroves, and they is a very important ecosystem for them, for the region. There are other countries in Latin America that also have mangroves as a key ecosystems. And carrying out this study, we left aside rock weathering and oceans alkalinization, and also the direct air carbon dioxide capture and storage, because those are not really, we don't have information. In the first case, we have some academic studies, but for the second case, it's still something really away from the agenda in our countries. We have not had a conversation on that. There is no evidence, so carrying out a study on that will be a waste of time. So we decided to focus on the five first that are really relevant for the information that I gave to you. Are really relevant for the region, and there are a lot of potential. So in all the study, what we carried out was complemented by the cost and co-benefit analysis. We also make risk analysis and some scientific and technical research, and we assessed some pilot projects. That was the feeding of our study. We also, next please. We also had to acknowledge that we have a lot of limitations still. We need better understanding of impacts. Some socioeconomic impacts are not well documented. There are lack of historical statistics, and comparison among countries that is required. It will benefit the outcomes. The assessment of technologies relative risk is not yet possible for some of them. Uncertainties from incomplete knowledge, complexity of ecosystems involved in an interaction emergence from a combination of options is unlimited. So from this study, next please, we have for Argentina, I will not go into detail because the figures are really in a very small font, so I don't expect you to see all the results. But the interesting thing is that we have in the first column we have the potential of Argentina of CO2 emissions reductions according to afforestation with one and two different scenarios, with BECS also in two different scenarios, and with biocharge in two different scenarios. We also have for the other two, but I don't have, no, in Argentina were only four interventions, so there is another raw, but the PPT couldn't host properly the fourth one. But I just want to encourage you to go into our webpage and to see what is there, because this study is already there. If you're working in Latin America and the Caribbean, it could be interesting. But if not, and you are in other countries, in other regions, then you will really find that is really interesting. This study, it's a very preliminary approach, but it give us very important hints for public policies. One of the good things is that in Argentina, the cost of greenhouse gas reduction by ton in afforestation is really a good deal for any investment. So that's a highlight here. And the next one is, please, is from Colombia. And next one, please. And the highlight is on mangroves because it has a lot of co-benefits and also have a huge potential on reduction. It's a little bit more expensive than forestation, but anyhow, the revenues in carbon capture and also in co-benefits are amazing. So, and we have independently from this study, we have a study on the Cuban mangroves, and that study reinforced these numbers. So in Cuba, mangroves conservation has a lot of co-benefits. It is not focused, curiously, on mitigation, this study on Cuba, but we have a lot of information on how it improves the economy of the regions around the mangrove, and also how it protects from extreme weather events, hurricanes, all the territory. So I leave it there just for questions, and thank you very much.
Thank you very much. As usual, we are getting into a time constraint, but stay with us. You might even get a chance for one or two questions. But we have three more very interesting speakers. We have, and I give now a preview. So we have James Mwangi, who will talk to us about opportunities for large-scale carbon dioxide removal in Africa. Then we're going to take into a focus of a country, Senegal, who is represented, or Cheikh Sylla, the Director of Cabinet of the Ministry of Environment and Sustainable Development, is here. So let's make sure that we can also hear him still. And then most importantly, we'll have a person again from Senegal, from the younger generations, who will have to implement all of this and will have to make choices in the future. And she will share with us what her perceptions and thoughts around these issues are. So let's stick around, and I hope we can get to some questions. We have to leave the room, as I'm told, by 4:30. So I'm sorry for the speakers coming, that I have to put pressure on you, but let's try that. I think we have time for you to make your presentation as planned. Go ahead, James.
Thank you, Carl. I will try to be quick, and that work is made a little bit easier by the fact that some of the points I would have spent time contextualizing, I'll just say similar to what you've already heard. But I'll give you a little bit of context for where I'm coming from, because I am making a slightly different argument than you often hear on the stage right now. The work I'm doing now with the Climate Action Platform for Africa is focused on the idea that the scale of climate action required in the planet and the economic shifts it will generate constitute the largest single opportunity for African economies to transform and attain durable middle income status and dignified livelihoods for their population. This is across everything from green manufacturing, a green transition from the outset, green competitiveness, but also in carbon dioxide removal. Now, you've already heard the case for the fact that we will need a massive amount of carbon dioxide removal by 2050. I think something we need to remember, and hopefully it goes without saying and should really be at the heart of the conversations at the COP, is the principle of polluter pays. So we need to separate the question of where carbon dioxide removal happens from who bears the cost. as we do with any other waste management issue. Someone pays someone else to take care of the issue, right? So if that is the case, and if we know that we're going to need a massive amount of carbon dioxide removal, it's fair to expect that there will be a tremendous market for carbon dioxide removal over the coming few decades. And the question becomes, if you're a continent in search of economic opportunities to grow, is can you be competitive in these new industry sectors that are still tiny today, but will, of necessity, unless we choose as a species to go extinct, those sectors will have to get pretty big. So this is not about African countries reaching into their pockets and paying for carbon dioxide removal because they didn't cause the issue. It's about them readying themselves to be the biggest exporters in the world of carbon dioxide removal. Now, when I started looking at this, I was very focused on land use and nature-based solutions. And I am really glad that you got the presentation that covers exactly the scale of the opportunity, which is very similar between Latin America and Africa around nature-based solutions in a number of countries. So I'm not going to talk about that because, Carl, I know you've got a clock ticking. Where I am going to say something is around direct air capture and storage, carbon capture and storage, because this is an interesting one which is often dismissed as completely irrelevant to Africa, right? It's that division between green and chrome, and green carbon dioxide removal needs to happen in the global south, and the high technology chrome-based stuff will be done in the global north. But that ignores the fact that most direct air capture technologies have a huge dependence on geology, and all of them have a huge dependence on energy. If you are in an energy system that is largely, that contains substantial amounts of emissions today, it is illogical to the point of stupid to take some of that energy that's coming from a stack that contains some emissions and use it to do removals. It makes no sense. Just stop doing the emissions, right? First, before we 2 steps forward, 1 step back, stop doing that. First, cut out your emissions, and when you get to 0, then you start doing removals. Where it does make sense to turn renewable energy or green energy towards removals is in places where there is no competing decarbonization use of that energy. So you need places with a lot of renewable energy potential and no competing use for that energy in decarbonization. That kind of describes the entire continent of Africa. If you look at a map of current energy demand versus available renewable energy resources, you quickly realize that almost every African country today has a superabundance of renewable energy potential. Superabundance is 1,000 times more renewable energy available than is currently viewed to be in demand. Now, there's a problem with how we are defining demand because these same countries are tremendously energy poor. But the problem is the people who need the energy can't afford to pay for the energy. And so you end up with only Africa as a whole, as a continent, gets less than 1% of global renewable energy investment today. Imagine that. With the price of solar panels collapsing, the sunniest continent, by any objective measure, is getting 0.6%, less than 1 cent out of every dollar spent in rolling out renewable energy technologies today is being deployed in Africa. Now, the reason is we don't have the bankable cases, right? We don't have the use cases to draw it in. And so when you're thinking about why direct air capture is interesting, it's around helping us make a different case around energy economics. Because what you need in order to justify expanding your grid is a use case, is an off-taker. An off-taker ideally who will pay in hard currency. So if we're saying polluter must pay, and there will be dollar flows for durable removal such as those by direct air capture. And if we're saying we have the cheapest renewable energy in the world, if we bother to put out a solar panel to catch it, and if we then say we also have storage solutions available to us, and I'll come back to that in a moment, then it stands to reason that probably the only place on planet Earth where you can get to gigaton scale of engineered removal, such as direct air capture, is Africa. If you just walk through the logic of this in the near term, it's the only place that you can do it. Now, this requires you to have a storage solution, and that was, a lot of what's been done in terms of carbon storage has relied on cap rock technology. You inject it into emptied out fossil fuel fields. But the gold standard in geological storage today is mineralization, as practiced by the Orca project in Iceland, where you inject supercritical carbon dioxide dissolved in water into geothermal fields, into porous basalt. And when it gets in there, it turns into a rock. Never comes out again. Importantly, the process of this injection is the exact process that happens when you're generating energy from geothermal power. You're just re-injecting, you're just adding more CO2 into the water you're injecting into the ground. Now, one of the fastest growing deployments of geothermal energy in the world is in East Africa, in the Great Rift Valley, Kenya and Ethiopia. Kenya has 10 gigawatts of proven geothermal potential. It's currently producing just under 1 gigawatt. Many people are surprised to learn that Kenya generates more electricity from geothermal than Iceland. There are over 400 wells already drilled. It also has a lot of porous basalt. Oh, and by the way, 10 gigawatts, the reason we have only developed one is there's no demand for that additional energy, no bankable demand. And so I'm looking at my fellow Africans here and saying, the universe is shouting at us. There's a massive industrial opportunity here if we can get our act together and compete. Other places in the world are competing to be the first to deploy really cost-effective and scalable DAC, and yet Africa, endowed with all of the factors you need to do it, is largely removed from the conversation. And so my challenge is, how do we begin to shift the thinking from the outside world about Africa, because you will get more direct air capture removal per dollar spent in Africa than almost anywhere else in the long term. In the short term, you have to work through some things. And from Africa, thinking, here's something that has huge co-benefits from the energy system, because what you're doing is you're putting more power on the grid, you're making it bankable, you're increasingly making your grid more stable, and you're then able to industrialize and generate jobs off of that. So how do we tie those things together and create a value proposition that allows this technology, that's one of those things that we kind of miss in the corner when talking about climate, to be recognized as one of those where Africa could actually not just compete, but lead. Thank you.
Thank you, James, for changing the perspective and a different approach and highlighting the opportunity from your perspectives. Cheikh, Sylla, over to you. I introduced you right away. Thank you.
Thank you very much, Kai, and thank you also C2G for the opportunity. My presentation is in English. Maybe I will have some time to speak French because you have interpreter, right? Yeah, okay. And this presentation is just in the African perspective on how we can engage or not in this removal. And we have 3 steps that I will describe. We already have conducted a study on geoengineering and Africa perspective, posing the problem, the vulnerability of Africa, the element for positioning and refining. Next, please. I forget to follow. Okay, to follow on the screen. And this study was prepared by some experts in Africa. One of them only is here, Mr. Fall. I don't know if he's from Senegal. And with the use of Regional Center for Basel and Rotterdam Convention assisting for this study. And after this study in September 2020, we had an African climate change workshop on geoengineering in Nairobi last January. And I'm going to summarize some key messages and highlight them. And I will not come back to these what are the impact and the risk for Africa, the opportunity and also implication for Africa on geoengineering. I think in the last presentation those was highlighted. And in the discussion, participants highlight that Africa is deeply concerned, and we have a global ambition of commitment to address the global change crisis, which is very insufficient and will not limit global average temperature increase to 1.5 degrees. And we know also that Africa is very vulnerable and will face several impacts, and also the impact added to the geoengineering CDR and SRM technology will add a further burden on a continent already experiencing climate change and its impact. We know also that this technology, largely in developing countries, will result in countries shying away from their UNFCCC obligation to implement and finance mainstream proven policies, technology, and measures to achieve one, the actual and real reduction of GHG, and to build resilience and adaptive capacity. Africa also faces the governance for this emerging CDR and SRM technology, and so that will take time to develop potentially further and divert political will and resource away from obligation to implement and finance proven policies, technologies, and measures under the UNFCCC framework. We have also a high degree of uncertainty around this technology, because if you want to proceed with through the UNFCCC, we need to fix how to make the inventory, how to make the calculation, how to put it in a report, in a record, and so that all this methodology will take time. And Africa should, by the way, not support at this time their application at this stage, but should rather support the development of an authoritative scientific synthesis and review of the state of knowledge of the technologies, assessment of their potential benefit, cost, risk, impact, and the implication. And we would like also to have a mandated body such as IPCC with a view to informing and possible international policy debate on science risk-based international management. But now, let me a little bit move in French. Donc, l'Afrique est concernée sur ces technologies en termes de situation de connaissances et des impacts transfrontières qui vont avoir des implications sur beaucoup de secteurs donc dans les pays africains. Et par rapport à ces impacts transfrontières et leur potentiel, parce que des fois ça peut être très important, il est important que ces technologies-là soient considérées par donc, un système donc, des Nations Unies, comme je viens de dire avec l'IPCC, sous la Convention changement climatique, avec des évidences donc, scientifiques, techniques, administratives, politiques et de niveau légal. Nous devons aussi reconnaître que avancer unilatéralement ces technologies dans certains pays n'assure pas et ne rassure pas aussi l'Afrique par rapport à toutes les connaissances qu'on doit avoir sur ces technologies avant d'y adhérer. Il s'agit de faire des renforcements de capacités, de consolider nos connaissances sur ça. Et d'après beaucoup d'Africains, l'Afrique n'est pas encore prête à supporter donc, et à s'engager dans ces gouvernances internationales qui demandent donc, que des technologies soient prouvées. Ensuite, par rapport à tout ça, donc, la recommandation phare, c'est qu'il y ait un système des Nations Unies. I'm sorry, I didn't follow I don't follow the screen. Okay, you can again. Okay, yeah, here. So just for two. Et donc, on doit avoir un système pour gérer ça et qui est un mandat très clair pour engager l'Afrique dans ça. Et nous avons donc, par rapport à cette étude, par rapport à cet atelier qui s'est tenu à Nairobi, donné mandat au groupe africain de négociation sur le climat de donner son avis. Next, please. Et donc ça, c'est l'étape 3, donc la dernière étape. Et pendant la réunion de la conférence des ministres africains de l'environnement à Dakar du 12 au 16 septembre, il n'y a pas eu de rapport du groupe de négociateurs sur le climat. Et ce groupe de négociateurs sur le climat a demandé que l'agenda soit traité en questions diverses. Cela veut dire qu'il reste dans l'agenda, mais n'a toujours pas donc, de développement futur ou bien en tout cas immédiat. Donc la question qui se pose pour l'Afrique, c'est quand est-ce qu'on va donner un point de vue et est-ce qu'on va continuer à ne pas considérer la question parce qu'elle est là, il y a des pays qui ont commencé à l'utiliser. Est-ce qu'il ne faut pas tout de suite commencer à poser la problématique de ces technologies-là et l'amener sur la scène internationale dans les négociations comme on a dans la COP pour qu'on commence à en parler. Ce n'est pas parce qu'on en parle qu'on va l'accepter, mais qu'on ait en tout cas toutes les recommandations et les exigences utiles pour être sûr que ce qui va être utilisé dans cette technologie-là puisse permettre qu'on puisse s'engager en n'oubliant pas de maîtriser les impacts que ça peut créer dans d'autres pays, etc. Et donc, sur ce, c'est une question qui reste ouverte et pour laquelle je pense qu'on a encore beaucoup de débats devant nous. Je vous remercie.
Merci, Cheikh Sylla. Maintenant, Adama, Aicha, Sagna, I hope I pronounced the name well. Thank you for having the patience to wait until now. I have to ask you to be brief, but you can dare the people trying to get in the room. Over to you. I think your slides are ready. Over to you. Thank you for your thoughts.
Merci, Président. Donc, malheureusement, moi, je vais faire mon interprétation, ma présentation en français. Bonjour à tous, moi je m'appelle Adama Aicha Aida Sagna, donc je suis étudiante en éthique, gouvernance, responsabilité sociétale, environnementale à l'Institut des sciences de l'environnement de l'Université Cheikh Anta Diop de Dakar. Donc actuellement, aujourd'hui, je suis avec mes collègues Fatou Diop et Pape Matar John, avec qui on a fait cette présentation ensemble. Donc, qu'est-ce que cela signifie pour l'avenir? Sans transition, je vais parler d'une façon très ramassée, pour nous permettre d'arriver à temps. Donc, vous me permettrez juste de vraiment, parce qu'au début, je me disais, est-ce que je suis à la bonne table? Est-ce que je ne me suis pas trompée de salle? Parce que je suis entourée par ma gauche, par ma droite, que du GIEC, d'experts, vraiment du climat, un débat de très haut niveau, de très haute facture. Merci beaucoup, en tout cas, M. Sylla, de nous avoir permis d'assister à cet événement-là et au C2G. Et on espère, avec toute la promotion RSE 10, que notre collaboration ne se limitera pas à Sharm el-Sheikh. Donc, slide suivante, s'il vous plaît. Nous allons ramasser le contexte d'une manière générale. Voilà, déjà, le protocole de Kyoto, on sait que la science est consciente que les changements climatiques ne cessent d'augmenter. En 1997, nous avons le protocole de Kyoto avec des engagements. Malheureusement, on n'a pas les résultats escomptés. En 2015, avec l'accord de Paris également, avec les CDN qui ne promettent pas de réduire ou bien de stopper les émissions à 1,5 degré. Et même en 2022, les scientifiques se sont posés pour parler de technologies de géo-ingénierie, entre autres. Donc, ce sont des solutions de technologie exactement, qui nous permettent des technologies et mesures de modification du climat qui sont censées renforcer ces efforts-là accomplis en matière d'atténuation pour combler les manquements des approches existantes. Slide suivante, s'il vous plaît. Alors, comme toute technologie, donc, ces technologies-là ont des opportunités et des défis. Donc, l'opportunité majeure, l'objectif global de ces technologies-là, c'est de réduire, voire limiter le réchauffement de la Terre à 1,5 degré. Donc là, nous avons, quand nous limitons les émissions à 1,5 degré, nous avons le contrôle sur la situation sanitaire parce que nous savons que les changements climatiques entraînent de nouvelles maladies. Nous avons l'amélioration de la situation socio-économique avec le reverdissement de certains secteurs comme le secteur de la pêche, le secteur de l'agriculture. Nous avons la régénération des ressources biologiques, l'amélioration de la qualité de l'air qui pose énormément de problèmes avec la pollution et les autres nuisances sur l'air. Nous avons également la stabilisation des conditions météorologiques d'une manière générale. Slide suivante, s'il vous plaît. Alors, concernant les défis, pour le défi majeur, nous pensons que c'est la maîtrise en fait de la chaîne d'impact. Nous nous posons énormément de questions à travers en tant que jeunes, nous nous posons énormément de questions à travers ces nouvelles technologies-là de géo-ingénierie. Par exemple, nous avons la réaction de la biosphère. Comment la biosphère va réagir par rapport à l'utilisation de ces technologies de géo-ingénierie. Nous avons la gestion de la santé et de la sécurité des communautés, la préservation des écosystèmes, on ne sait pas, c'est des questions que nous nous posons. Nous avons également la préservation de la biodiversité, l'approvisionnement de la couche d'ozone avec l'utilisation d'aérosols. Slide suivante, s'il vous plaît. Quand nous parlons également des défis, la première des choses qui me vient à l'esprit, en fait, c'est la gouvernance. Comment est-ce que les États seront impliqués? Est-ce que les États réellement auront la volonté d'aller vers ces technologies qui sont actuellement à un stade de mise en œuvre embryonnaire? Est-ce que réellement les États seront impliqués et des communautés également, et avec un modèle de gouvernance à mettre en œuvre? Nous avons également les questions de recherche, les conséquences des technologies à long terme, la réponse du système climatique, la sensibilité environnementale et sociale, des répercussions sur l'environnement, les mesures de maîtrise et de mitigation. En tant que jeunes, ce que nous avons aujourd'hui, c'est que des questions. Nous ne posons que des questions à travers l'incertitude de ces nouvelles technologies-là. Elles peuvent nous permettre aujourd'hui d'atteindre ou bien de limiter les émissions à 1,5 degré, mais à quelle fin, à quel prix? C'est des questions que nous nous posons. Merci, Monsieur le Président.
Merci, en fait, de cette... Oh, sorry, I have to speak English. My French is gone. It's too late in the day. Thank you very much for this concise and very well-delivered last presentation as well. Now, I'm not so sure. I don't see anyone trying to break the doors, so maybe we can dare to have at least one or two questions, if there are any. Well, yes, I see one over there. Alia, can you help with the microphone? Sorry. No, they're okay. Oops. And if there's anyone else in the meantime, if you want to raise your hand or you wait for the first question, up to you.
Hi, my name is Anja von der Ropp from the World Intellectual Property Organization, and we have seen that whereas other green technologies or sort of innovation as measured by patent applications have grown, for carbon capture and storage they have gone down over the past 10 years and by 30% even. And I was just wondering whether you had any answers how that could be explained given the rising demand for such technologies. Thanks.
Okay, and we take maybe the second question just here in the first row. And then you can think about who wants to take the question number one and then number two. Yeah, Alia.
Hi, thank you so much. James, I was so inspired by your speech. It was absolutely amazing. You said that the sunniest continent by any objective measure is getting less than 0.6%. That's less than 1 cent of every dollar spent in rolling out renewable energy technology. and that is a super big deal. So what can we do to increase that investment, or through maybe a carbon credit scheme to help fund this type of investment?
Okay, thank you. I need the panel. Who would like to take the first question, explaining basically the kind of lack of investment and interest in carbon dioxide removal technology, CCS? Maybe Ceri?
So I wanted to make sure I understood your question correctly. It was that the number of patents filed is reducing? Okay, so I think that there has been a lot of commercial development on capture, and I have to say I am in the storage side of things, so perhaps this is not my area to answer, but we see that CCS is being rolled out and the technologies are very well developed, and there is innovation indeed looking at these patents. I have heard concerns that because capture is expensive, it is difficult to innovate for smaller companies, and perhaps this could be addressed with more technologies being easy to access by looking at the existing patents, by being able to develop innovations around this. But I don't see the decline in patents as a signal that CCS is declining. In fact, I see CCS deployment growing, and I think that is a really important measure, that we see CCS growing, we see the pipeline of projects coming online is growing, and I think these are positive signs for CCS. And we also see investment in CCS is growing too. So we have a few projects going to tens of projects and hopefully to hundreds of projects. So I think that although maybe patents filed is not increasing, I think the deployment of the technology is increasing, and I think this is a very positive sign. Thank you.
Thank you very much. James, I think this was directly for you.
Thank you. I love that question because it's a question I wake up every day kind of thinking about, is what's limiting investment in Africa's energy potential. And I think it comes down to the fact that while the cost of energy supply, renewable energy supply per unit, is coming down precipitously, faster than anyone could have ever imagined, not enough has been done to flesh out bankable demand. And so you can subsidize and so on. It doesn't change the fact that when you're trying to roll energy onto the grid, you're asking a government, usually a very poor government, to promise to buy all the energy that the generator will sell. And if it's a poor government, they have very limited space to make that promise. In a sense, they can't really sign those power purchase agreements. And if they can't, and if there isn't another off-taker ready to buy the energy, it just stays there. In theory, there's energy wealth, but because there isn't that bankable customer. And my grandmother in the village, unfortunately, is not necessarily a bankable customer because she can't commit upfront to pay for the energy. And so there you're relying on the government's ability to basically carry this on its balance sheet. And that's why for poor countries stuck in that poverty trap, they often have this wealth of natural resource in form of renewable energy that they can't access because they can't get demand. And the reason the energy hungry demand isn't coming is because energy costs are too high in those countries. The reason the energy is costs too much in those countries is that there isn't enough of it being produced. And the reason there isn't enough of it being produced is that there isn't enough demand. It's crazy, right? So the way you crack that is you look for chances to bring supply and demand together onto the grid. So you're saying this is not being guaranteed by the Kenyan government. It's being guaranteed by DAC player X or green hydrogen player Y. And as a result of that, you're then able to unlock some of the potential. That's at least what we think needs to happen. But it's one of the things that need to happen. There are a few other things, including ending the, people call it the zip code premium that Africa pays. I'll call it the prejudice premium that Africa pays. The cost of borrowing to install renewable energy in Africa is just unreasonably high. And because the biggest cost that drives renewables is your cost of capital, it just makes it more expensive to go renewable. So it's a multi-hour conversation, but those are the 2-3 things that I'd be most focused on, and why I think direct air capture is one of those weird things that could actually be really interesting as a way to address energy poverty. Hope that answers your question.
Okay, thank you very much for the answers. I think we don't have time for any further questions. Also for my closing remarks, you are happy, they will be long and boring, so you are spared with that. Thank you very much for you coming and listening to this kind of wide spectrum of information, knowledge, and ideas on the subject matter, which fundamentally I think we can summarize is it's a challenge we are not able to avoid, but we have still the opportunity to define how we address the challenges, how we make choices, and how we limit the use of that by, investing as much as we can in emission reductions. With that, thanks to all panelists for being here. I hope also you had some new aha moments by listening to your colleagues here. Thanks for the colleagues from Senegal